Did that work? Yeah, it did. Look at that. Now let's tell the internet. I should probably get the... The question is, where is it? As it always is the case. Looks like I'm clipping visually here. Got my adult spicy beverage. To Mastodon. There's always a process. Okay. I will be pausing to go and refill my drink at regular intervals. I will get progressively drunker as I work on this. I have not had anything to drink yet today, though. So, just this. Yeah. So, there's like a few things that need to happen. There's this guy, process model. I have to this is going to be a whole damn thing. So basically, I was doing palette stuff. Now, I actually just split it into classes and properties because, yeah, you got classes. Those are the ones that I started out with, these guys. And then I added, this is what I added today. And this is a bunch of shit that I've been meaning to add for a while. And then properties, again, this is what already was here. Of course, you can't see it when it's highlighted. This is crap that I'll add it today. Yeah, anyway. And then these are some icons. They're just like the hex code for them. Probably gonna need to download a new font awesome or whatever the heck. And I'm gonna have to probably flesh out the CSS, which is fine. So yeah. Oops. So that is that is this, that is this. Is this? No. Yes. No. No. Why is everything so stupid? Okay, we don't need you. No. Whatever. I'm gonna fish this out again. I don't know why I closed the window on it. That was dumb. Dumb. You can see all the slowness that is this friggin' thing because there's no caching on it. But anyway, picked a bazillion freaking colors today. I mean, I picked the hues and then I had something generate the color ranges, and then there's other stuff that goes and like assigns it to its proper whatever. Actually kind of wouldn't mind like a better thing than this, but I'm lazy. So, anyway. So, basically, today's job, now that I spent the entire freaking day just picking colors, I was like, the thing to do at this juncture, oops, that's, okay, whatever, I don't know what that was, this guy. So this is, wow, it's a lot of things. I thought I had that going top to bottom, oh, whatever. Maybe I did. Maybe I need to just refresh that. No, I definitely did not. Anyway, doesn't matter because, so, actually let's go here and see if this is loaded yet. Okay, sure. Let's just grab that. Again, this is going to be freakishly slow because I'm running OBS and there's no caching. Anything. So, current status is I spent all day friggin' picking colors. The colors correspond to a set of properties and classes, and they get generated out into a thing, but you can see them, like they're all the keys down here. These are all properties, these are all classes, whatever. And then they get like merged at the bottom, whatever, just as you'd expect them to. There's a bunch of them that I haven't done yet because I have like no idea if I even want to represent them in a graph. Still not loading. Jesus Christ, man. Oh yeah, no, I know why. Because not only is it has to like cache internally like a bunch of URI resolutions, so no freaking wonder it's gonna be slow the first time it starts up. Give it a minute, like literally. After it loads the first time, then it's like a little bit better. But anyway, you will see as I load this thing, as it takes, God, man. Okay, we got a load of 455. That's a lot of load for a little computer. Whatever. You know what? Maybe while it's friggin' still loading. Okay, this is, I don't know if I need this still. This is Protege, if you've never seen Protege before. Protege is like, it's like an ontology browser. It tells you like how to connect things to things. It is, I don't know if I can make it bigger. No, I can't. I mean, I can make it bigger probably in the like Java config or something like that. But anyway, it's taking up RAM. I'm just gonna kill it. Are we loading it? Oh, there we go. Okay. So, yeah. So this is the IBIS tool. Blah blah blah. I'm not going to talk about the IBIS tool right now, but what the job is like I need to add like an entire new like family of thing or multiple families of things to this. And so right now you've got like issues, positions, arguments, and concepts. I don't know what happened to the concepts. It's probably because there aren't any. It's fine. And so what I have, so this, like what this models is a I'm going to switch up my lights actually. So what this models is it's an issue network. You start off with an issue, a thing in the world you want to do something about. Position is what you want to do about it, and then an argument is why or why not. So this issue has positions. Positions have arguments. So either this. So you can go to the argument. That really slows down when OBS is on. Holy cow. There's like something that I'm sure I can do that will speed this up like by quite a bit. And that's put a global modification time on the database. So like if the database has been modified like since you loaded the page last, and like has not been modified, I should say, since you loaded the page last, then you can 304. Anyway, so that's the argument for Docker. You can see there's the position. Okay. So I have been using this. This is not my ontology. This is something somebody did like 50, 60 years ago, something like that. 55, whatever. Sounds right. Yeah. And God, that is slow. I can't wait to speed that up. I can't wait to just spend some time just speeding this up. But we're not there yet. God, and I got to fix the math on this visualization. The math isn't right. So many things to do. But anyway. So, you can see it lighting up stuff. It lights stuff up when you ring the bird. What is this guy? So there's like all these things, whatever. You get it. It's showing all the things. So this is this, and all of these are the neighbors. Okay, cool. So the problem with this ontology, or if you can call it a problem, is it's not meant like there's a sort of extra layer that I designed on top of it like a number of years ago that sort of concretizes. So like you start off with these issues and positions and arguments, and that's all fine and good. But like, what if you wanted to actually concretize this into like tasks and like make a structure of, you know, tasks and methods and whatever, so you can actually implement the thing and then like determine like the value and what have you. So that is actually, I should do that. I should actually have a value, like a PM value on the goals. Anyway, we'll get there. Actually, we can do this right now, because we can say we can find the thing first of all. Where is it? It's probably down here. Is this it? Part of the IBIS tool didn't show me. There it is. Think about when you pour like a gin and tonic in a rocks glass, it just goes really quickly. Anyway, God, you're slow. Why do you gotta be so slow? So that's what we're talking about right now. Now, what do we do with the port? I'm going to sneeze any second. So what do we do with the port? Actually, that's a good question. So we would go to this issue, and if you can like put up with the slowness, oh my God. Maybe I should like cut an instance, like do an instance of this that just has this stuff on it. Should have thought of that. Because like part of the reason why this is so goddamn slow is it's like doing way more work than it needs to, and part of the reason why it's doing way more work than it needs to is because it's got a lot of shit in it. That, yeah. Anyway, it's fine. What do we do? What do we do? Has response. Add functionality for yes. Okay. Organizations and products. That's one thing. Another thing is add the process model ontology. Extend the IBIS with the PM. IBIS with the process model ontology. Boop. Do not forget, let me forget to export this before I nuke this database again, which I have been doing on a semi-regular basis. Gonna dump the database first, otherwise I'll lose all this work. Which reminds me, I don't actually have a mechanism for that quite yet. I mean, like the old IBIS prototype did not have, or just had like a URL you could go to that would just dump its entire contents and you could just save it to a file. This does not have that, which it probably should. Okay, so that's done. So the other thing too is also client wants to be able to use the process model ontology. That's another important aspect to this is something that the client wants. It's not just something that I want for myself. And then, God, that is slow. Come on. Gotta have an ellipsis. Okay, so yes, client wants to extend IBIS with the process. But the client wants to use. We can also like add. This is another thing. We can just get rid of this and go here. We can go. Damn it! This is when I get lost. Okay, 3. We can that. That doesn't have a read ahead yet, but it will. Oh, I shouldn't have done that. It's too slow. Yeah, I should not use the main instance of this on stream because like the main instance is just like full of crap. It's got like, cause it's running on top of Intertwingler. Intertwingler is the application server I designed. It ends up loading like all sorts of shit from all sorts of stuff, like all sorts of like every web property that I have and every like weird piece of metadata. Like it's got all of it in there. So like, just as a for instance, like, so there's like the way that it knows that I'm me, it like hops. So like it does like it does Hados, whatever, hypertext as the engine of application state. And so what it's doing is it's traversing links to find the fact that I'm the one using, like I am the current user, for instance. But when it gets to that page, like that is like crapped up with like a jillion backlinks of like me, the creator of X thing, where like that's like thousands of objects, and so it's just this like list of thousands of links, which of course is loading every goddamn time. So that is part of the reason why it is slow. I had to prune that down. That's like, yeah, not the best design. But then, you know, we know about this, so it's not a problem. Okay, so client actually wants to be able to use, so this is actually something that is a specialization of client wants. This guy. Actually, this. Yeah. So anyway, when the graph is like empty, except for this, it runs a lot faster. When it's full of crap and I add caching to it, then it'll go considerably faster. There's also other stuff too, like this graphic, like this is a Sugiyama, and it's the same algorithm as GraphViz. It's just been put around a circle, and it's actually extraordinarily expensive to compute so there's the ranking, which is like not that expensive, but then there is the uncrossing, which is crazy expensive. And the more nodes you have, I can't remember what it goes. It's like a O to the n squared at least, if not something bigger. But it is anyway. It only needs to be computed whenever the graph itself actually changes, and it's currently computing it with every page load, which is dumb, but. You know, there's only one me for the moment, so, and also too, like I realized, like, I mean, this never looked quite right. It's got a whirl around it, but it's never looked quite right to me, and I realized that if this, because it's in hyperbolic space, and the thing about hyperbolic space is when you get farther away from the origin, like the farther away stuff is, like it adds space the farther you get from the origin. And why am I clipping on the frickin'? Anyway, it adds space, and so like these points out here are like miles apart from each other, whereas these are like inches apart from each other. Is basically the situation, and this is like straight up not correct. I'm gonna turn off the heater. Makes a lot of noise. Anyway. What are you looking at right now? You're looking at, this is a tool for collaborative planning. It is based on, I guess we're going to do the IBIS spiel. So this is a tool for collaborative planning. What it does is, it enables it basically is, it was designed by some guys in the 60s. They did it on index cards, and you basically, like, it's for the guy in charge, his name Horst Riddle. He coined the term wicked problem. And the essential idea behind this thing is it is a mechanism for basically collaborative problem solving of like hard problems. And it's a very simple model. Again, they were doing it on index cards. You can look it up. It's called an issue-based information system. You've got three kinds of entity. There's an issue, which is a thing in the world that you want to do something about. There's a position, which is what. and then there's an argument, which is why or why not. And then you go around and you like say, okay, here's the thing. And then somebody says, we should do this about the thing. And then somebody else says, yes, we should do this about the thing because of this. And then, oh, wait, that raises this issue. And, oh, wait, we don't want to do it because of this, blah, 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 blah. And it goes around and around and around, and it makes these, like, deep structures. And once you've got this kind of deep structure, so it's kind of like, imagine, like, a structured bug tracker for, like, everything. Not just software, but, like, everything. And so, what this is my take on it. People have been digitizing these things for freaking ages. So the first guy was named Jeff Conklin. He had a company called Compendium. Compendium still exists, although they're not like really centering this stuff. But he was doing it on Sunboxes in 1987, 88. This paper is from 88, but you can see this says 1987 right there. I don't know if you can, but anyway, that's a Sunbox with their thing. It's got some box arrow stuff. Now, my design, the reason why I did this is because like the dot in the center, which is this guy, is the same thing as the thing that's being represented on the left here, and then the immediate neighbors, you can see it better when I like wave the mouse over them, whichever direction that goes. There's one. And where's the other one? The other one? There it is. That. Anyway. So I was doing this stuff. Like I was interested in modeling, like doing like time estimate stuff for software development and getting accurate estimates. And I invented this thing called the behavior sheet. That was back in 2006, 2007 maybe. I can't remember if it was 6 or 7, but it was one of those. The idea is you just get an outliner, like a freaking whatever, like org mode, Google Doc, Obsidian. Of course, none of those Google Docs and Obsidian didn't exist back then. Org mode did, but Omni outliner, whatever outliner, and then you would like make bullet points of like what the software must and must not do. And you just keep going and going and thrashing that out until you've like basically described all of the things that it has to do and not has to do. And then what you do is you eyeball that and you say, that's 4 hours, that's 4 hours, that's 4 hours, that's 4 hours. You add that up, you get an estimate that is extraordinarily accurate. Now, the problem is those estimates took as long to do as it did to write the code. So like, your boss asks you, when is it going to be done? You're like, I don't know, but like I'll figure it out and then I'll come back to you in 3 days to tell you that it's going to take another 3 days or whatever. I was like noticing like, if I started this behavior sheet thing on a Monday morning at 9, I could tell you by Wednesday at lunchtime that the module in question would be done by Friday, at close of business, and with remarkable accuracy. But again, pointless. Because, why do people want estimates? So I looked at that and I was like, well, what if there was a way basically to sort of integrate and surface that work so that you could actually do it? And furthermore, like in the sense that like certain stuff got recycled, like, you solve a particular little problem and then you can actually address that solution and you can get it back and then apply it to some future work. So that like any work that you do doing this doesn't just get applied to the one thing, is the sort of idea. Now, so that was a sort of thing I was working on like almost 20 years ago. So 18 years ago or whatever, I was working on that. And never went anywhere because of a lack of it was a lack of, just basically nobody cared. And so so there was, where were we here? So I think it was like 2008 or something. I end up reading Christopher Alexander's notes on the synthesis of form. Ooh, that's not what we wanted. Notes on the synthesis. This is Christopher Alexander's PhD thesis. The guy who made pattern languages, etc. He, anyway, this is a short book. It's his PhD thesis that's been just retitled or whatever. Or I don't know if it was, whatever, it doesn't matter. And he did this in 1964, and he's like, there's a structure, inherent to any kind of, like you solve a problem by breaking it, a complex problem is solved by breaking it apart into smaller problems until you have a bunch of problems that are, recursively, until you have a bunch of problems that are small enough that you can solve. And then you add those back up and then you get the solution to your problem. Seems simple enough, makes a lot of sense. But there are aspects to it that are less than obvious. And so he's like, well, if you take all the things and you chuck them into a structure like this, and then you run some topological decomposition over it, what you get is you get this sort of like minimum cut substructure, basically, or recursive substructure. And then, that should basically be the solution to your problem. He's like, well, first of all, you just got to go and get all these nodes. And when I was looking at this in like 2008, 2009, the first thing I discovered was that like actually getting the nodes and putting them in here is like a huge amount of work. So, yeah, that was, so it was like, okay, like how do you do that? And furthermore, like I guess like, so I'm not exactly too sure on the chronology of this because if you look at the vocab for IBIS, which is this, the one that I wrote, which is this guy. My like time stamp on this is December 11th, 2012, like when I started on this. So this is the simple structure. This is based on these guys from Berkeley in the 70s, 60, whatever. I think it was, I think the first paper was the 70s or this 1969 or whatever. So practically the 70s. And then the process model ontology, which is derived from this for some reason, has a timestamp of July 22nd, 2009. And I don't know what I was thinking or where, because like this can't predate this thing by 3 years because this thing inherits from this thing. But the basic gist of this guy is coming up with a way to graduate this stuff. This is just like issues, positions, and arguments. But like if you want to graduate an issue into a goal, and then you want to graduate a goal into a target. So like having these sort of conceptual distinctions as well between you go back to like Alan Cooper or whoever, where he's like, a goal and a task is not the same thing. Like a goal is like, I want to lie in the hammock all afternoon. And the task is, well, I have to mow the lawn first or whatever. And, so these are just things that are fundamentally, these are distinct concepts. Not only that, like a goal is a state, sort of an instantaneous state, whereas a task is a process. And then you got like all of the different management consultants where like a goal is not a goal unless it's got a budget and a deadline attached to it, which I actually disagree with, which is why I made this sort of distinction between a goal and a target. So you can see this sort of inheritance, like, so the target inherits from goal, a goal inherits from a state and an issue, and then these inherit from a concept. And the same thing as a task inherits from the position. So what I need to do right now is upgrade this visual design such that it can accommodate the new types and relations. So what I was doing with all this palette stuff, and you can see like, you know, for example, like these are all the palettes that are currently, these are all the semantic relations that are currently represented. And then if you go and you look again on here, you can see that they're all there. And that's all just embedded metadata in the actual HTML. But that's neither here nor there. So what I need to do at this juncture is I need to add, like I need to basically keep adding a bunch of metadata. And part of what I need to do with that is I need to, like, so these things are the things that you'd use to add stuff. They're kind of still a little bit janky, but they mostly work. Anyway, so the response can have a position, this can have an issue, this can have an argument, etc. This can have a concept. It's like a thought bubble. You can't really see from here. So yeah, that is what I need to do, and now I need to sort of like remember what the hell. So I think what I need to do first is I need to branch this so I don't screw it up. So I think I committed this before I started, or did I commit it as I was doing it? No, it's just a bunch of junk. Yes. Okay, so I'm gonna just get to checkout -b, adding PM or PM ontology. Okay. Now, so there's a few things that need to happen. One of them is I ended up, as I was doing this, this stuff, I ended up adding a bunch, or changing a bunch of stuff, adding a bunch of reciprocal or inverse, whatever, inverse properties, and ended up like also thinking about the semantic relations as well. So, or just like the inheritances of it as I was working on this. And there's a bunch of other shit that needs to happen. So I need to add, this is the ontology itself. This is the ontology document. And I need to add the changes to that at some point. I don't know if I need to do that right away. I don't know if it matters. I don't think it matters. As long as everything is, like, as long as all the classes are in place, I think at the moment this is fine. Okay. So, all right. Where are we at? Okay. So yeah, we don't need to touch the ontology yet. We will, but we don't have to right away. So what we need to do is we need to just manipulate the front end. So we are going to go into the front end, which is this guy. This is a freaking antique. This is XSLT. And I still use it because I'm a crazy person, but also because it's like incapable of screwing stuff up. Like it just transfers over or transforms over markup, and it's like incapable of like giving you garbage. So, well, that's not entirely true. It was a lot better before changes to stuff. Anyway, so what we want, like basically, actually, like, so here. So what I need to do is I need to make 3 templates. URL, more context. Sort of. There is the summer protocols. If you go to, well, if you go to like, no. What I'm working on right now is more of a front end. That's a good question. Yeah, what I'm working on right now is more of a front end on top of Intertwingler. If you go to like Intertwingler net, this is on Twitch, by the way, not YouTube. Yeah, if you go to intertwingler.net, that's the that is the application server, but that's not. If you go to, that's not what I'm working on exactly right now. The ontology, so if you go to process model, you go to this guy, this is what I'm trying to implement right now. That is something that inherits from this. Come on. So that is the process model ontology is something that I did whole cloth that is derived from this. So I will just put this in YouTube as well. This and this and that. Okay. So what I'm trying to do is I'm trying to add the process model ontology layer onto this tool. And yeah. So what I got to do is I've got to add like the buttons here. I got to add a new kind of lozengey thing, and I got to what else? And I got to, and I've already done the colors, so those should just like JFW once it's up. So if you look at this screen, actually, let me just, oops. 3. If I get U2SO, U4SO, U5SO. There we go. Okay. So, like, you've got the sort of the main lozengey part, and then you've got like all of the neighbors, and then like depending on what class it is, the neighbors are going to be different. They're going to be in a different order. Like there's going to be different ones. And then the lozengey part itself, it's all the same for the IBIS stuff. But it's different for concepts, and it's different for concepts, and it's different for for the process model stuff for sure. So because you've got a goal, that's a good question. Is a goal the same thing? It's an entity. It might actually be. No, it doesn't. It's got extra. Well, no, it's got extra stuff down there, but it doesn't necessarily have to be. So, actually, we got to go back to the ontology for that. Goal extends. It's like slightly different. Task is definitely different, but these are all going to be, so the responsible and recipient. So the task, this is where we need to figure it out. So like goal has to have a, I'm going to get that in the frame here. Like, mess that up. Get back on there. All right. Come on. Is that in the frame? It is in the frame. So like if you go back, well, we've got it in the, well, we're going to go that. So actually, you can kind of see, so there's like, first of all, there's this toggle here, like these, like there's a lot of stuff in here. So like we'll just replicate that. So there's the toggle stuff there. There is the like main text field. There's the like refresh button there, which that is a vestige. That is like something from the 12 years ago when it was like back before, like I didn't feel like doing like some kind of Ajax-y thing, but also like I was very, very intent on the like anything JavaScript had to have like a non-JavaScript sort of like failover. Then there's like the reference by and see also. I don't actually think the reference by stuff is, so you got those down there, you got the little thingy there, whatever. And then you got all the neighbors. So first of all, one of the things that's going to have to go is this toggle thing. That's, you see the mouse, probably not down on the little guy there, the toggle thing. Because, I mean, for starters, it never actually made any sense. The idea that I had behind the toggle thing had to do with the toggle. The toggle thing was like if you had accidentally like set your thing to be the wrong thing. But what ends up happening is that, like, the wrong connections persist, and then it's like what do you even do when you do that? Like it just kind of like as a thing, it like kind of doesn't make any sense. So I kind of got to get rid of that, with the exception that I made arguments a subclass of issue. Anyway, so like that makes sense, but like switching from an issue to a position doesn't make any sense. This is not a thing that makes sense. So you should be able to like upgrade from an argument to an issue, but upgrade from an issue to an argument, but like you shouldn't be able to downgrade from an argument to an issue. This is actually something that should go in this tool if it wasn't being so damn slow right now. But anyway, I'm going to just keep going on here. So like a goal, and I'm going to put a target next to this. So I guess there's like, now that I'm sort of thinking about it, like there's not really like a heck of a lot of difference between a goal and an issue, except for the fact that a goal it's got like an extra, there's one thing that I haven't done here yet, and that's endorsements. So like very early on, like I was like, we should have like a like button for this so that if you endorse a thing, like, you know, it doesn't, you don't need to remark on it or anything like that. You just, you know, you can just, it's okay. I don't have to comment, you know, kind of a thing. Cause like all of you find in these systems that the comments are always like negative, right? Like, or not negative. There's not like, yep, looks good to me. You know, like there's no content in that. It's just, nyeh. Anyway, so there's this, the target, but that's going to still have the same sort of text fieldy, whatever, but like it needs extra stuff. So first of all, the target has a budget in it, or it's like a do, and it's going to have responsible or performer, responsible. It's going to basically have racy on it. I can't remember, involved or something like that. I don't know if I want to put racy exactly on it. That's another thing. So it's going to have do. It's going to have, and then it's going to have a value or cost or whatever allocation. I can't remember what I called it. Let's see. Target. Budget. Yeah. And then it's going to have like, but then like down here, it'll have still its like other stuff. And then it'll have like, yeah, initiates. There's other, yeah, so anchors. But then other than that, it's going to have all the same parts as an issue. So yeah, absolutely like having the ability to graduate an issue into a goal and then a goal into a target. So you've got this sort of like issue, goal, target. And then the task. Oh shit, no, the target doesn't have that. Target does not have that. Target has just initiates and anchors. But it's got the due and the budget, so it doesn't even have that shit. What am I saying? Target has a due and a budget. And it's got a status as well. Or what has a status? Issue. Maybe it doesn't. Maybe a task has a status. Yeah, because like an issues can only be resolved or not. Sorry, issue, yeah. Issue needs like a resolution. And that's the other sort of question too that it raises is like, well, should this actually be a IBIS thing? Because like an issue should have the resolution attached to it. Like, issue was resolved on this date, issue was de-resolved on this date, issue was re-resolved on this date, kind of a thing. So that is like resolution. Or state change. I don't know. That'll be prov activity. We're not worried about that quite yet because I'm not modeling that yet. But the task, so task, it could have a method. So it's going to have people responsible. Responsible, accountable, or performer. So this is kind of like an assignment, like a bug tracker at this point. We're talking. Responsible, performer, and then like involve. I don't remember what all the things I added to that. And then it'll have things like, yeah, achieves. Yeah, we got to work on this. You got like desires. Well, like a desires is a range is a goal. So this will have a desires here. Desires is like endorses plus plus, right? So that's like one different thing on there. It'll say who desires it, and that's kind of like an extension of endorsement. This is like another interesting thing here is that what you find when you do this stuff is, where is that? No, there we go. I don't know why I'm like transparent today. That's kind of weird. It's, you know what it is? It's like every time you update like OBS, or you know what it is? I'm wearing like a bluish shirt. So it's probably making me into a ghost. It's like a slate blue, green. Like it's a bit too green, I think, for this excursion here. Whatever, I won't wear it again. But yeah. So task is going to have all this extra stuff on it too. More. Yeah, sure, Everett. Let me think. So, I mean, I can give you the spiel. I don't know how much of it you heard, but so beginning back in 2006, 2007, I was working at a company. We were trying to scan the entire internet for like bogons, like sending email. And this was all original development. And so it was like, there's not a lot to compare it to. And nevertheless, the boss wanted estimates, and he wanted them quick, and he wanted them now. And I mean, of course, we didn't really even know what the hell we were doing, but anyway, but this one, he wanted them, and they wanted them to be accurate. And so, like, I spent a lot of time trying to figure out how to make accurate time estimates for software development. And I came up with this methodology that I sort of invented this thing I called behavior sheets. You take an outliner, doesn't matter which, you know, Obsidian, of course that didn't exist back then, you know, Omni outliner, org mode, Microsoft Word, doesn't matter. Could be anything that can make a friggin' tree of bullet points. And you would bash them out. You would say, this is, the software must do this, the software must not do that in bullet point form. And then you would like indent, like based on like, you know, sort of scope changes and stuff like that. It wasn't supposed to be pseudocode. It was supposed to be like a, it was supposed to be a design for just coming up with like, yeah, it was supposed to come up with accurate estimates, and it did. Came up with extremely accurate estimates. You bash them. Like, the reason why is because you would basically exhaust all the sources of surprise during the course of this exercise, this sort of thing called a behavior sheet. And you just, you know, you would end up like, even a relatively small module, you would end up with like, you know, a couple hundred of these bullet points. And like, they just take the form, must do this, must not do that. And then of course, within certain contexts and so on. And what I found was, yeah, you know, you could do great, you know, extremely accurate estimates, but the behavior sheet took as long to write as the code did. So like, that was totally useless for forecasting in any meaningful way, because the boss wants the estimate now. And this didn't give it to him now, even though, you know, I would argue that it made better code, and it actually made code sooner. So I obviously, like, this was a dead end. There was no point in doing anything with it. You know, so that kind of mothballed, whatever, for a couple of years, and then kind of resurfaced a couple of years, you know, in 2008, 2009, I was looking at Christopher Alexander of pattern language fame. I was looking at his PhD thesis called Notes on the Synthesis of Form, where the thesis is basically how do you solve a complex problem? You break it down into simple problems. You break those down. You keep breaking them down until you have a set of problems that you can solve. And then you solve each of those problems, and then you add the solutions together, and that's your solution. And his insight was roughly that there was several insights in there, but one insight in particular was, designers will agree in principle on whether or not a particular concern is valid, but they will not agree on whether it is important. And so, a solution to that is like you just throw it, you make a system where it is cheaper to just record the damn thing than it is to argue about whether or not it deserves to be recorded, because you've got infinite room for it, or at least, you've got so much room that you're never going to run out. And so there's that aspect of it. I don't really know what traditional approach you're talking about, because as far as I'm concerned, and from what I've seen, it's kind of an unsolved problem. It's kind of all of the solutions that I've seen, at least, in the last several decades, has been, kind of just faking it, really. It's kind of just coming up with guesses of how long you think stuff is going to take. I should also say that as far as I'm concerned, the cost or the time it's going to take to make software, and this isn't just for software, but this is anything that, it was originally about estimates. Definitely the part that I'm adding right now is 100% about budgeting and resource allocation. What you're looking at, is it going to change now? What you're looking at on the screen is a sort of abstract superset of this. So this is from the 1960s. This is like a direct, I downloaded a bunch of academic papers, I looked at them, and I wrote an ontology. I did that in 2012. And then a year later, in 2013, I had a technical thing that I needed to test. It was a protocol that I designed. It was a way to get RDF statements from a web browser to a web server without using JavaScript. It's like a protocol that embeds, if you look at the code, I'm going to just zoom this up here. I don't know if this is a good example of it, but sure, whatever. That needs to be fixed. Basically, you embed, I did this thing called the RDF KV protocol, and it embeds, it's basically partial statement commands to add and remove RDF statements, and you embed them in the keys of regular vanilla HTML forms. So this comes from me testing, needing something to test, frickin' 12 years ago. Not quite, it was in the fall. So just 11 and a half years ago, whatever. I needed a vocab to test it. I had written this other vocab, this one, in 2012. But the reason why I did that has to do with this salon presentation by Douglas Engelbart. Ooh, that's in the wrong machine. Hang on a second. So there was a salon presentation. It was like a chit chat with Douglas Engelbart. Where are we here? Come on, it's going to come up in the link history. I know you will. Come on, bastard. God damn you. Okay, let's check the history. Yeah, the mother of all demos guy. That should be this. Can I get that in there? Yes. So anyway, I'm just like chilling watching this thing. I just will put it in YouTube for good measure. Oh, God damn it. Jesus. So it's 2009, and I'm watching this thing with Engelbart. And it gets near to the end, and he's like starts talking about structured argumentation. And I'm like, what the hell is that? And so, you know, I go and I Google structured argumentation. Two things come up. One is this like defense, like counterterrorism thing that's like totally spooky, and you know it's kind of under wraps. There's like a bit of an academic kind of chat about it, but there's not really much else to it. And it literally is about like counterterrorism. It's like what are the terrorists going to do? What do you think they're going to do? That kind of thing. The other thing was this IBIS stuff, and I was like, holy shit, like what? And this goes back to the Alexander stuff, so I was interested, I'm going to get back into this a second. I should have done this the other way around. But the Alexander stuff in Notes on the Synthesis of Form, he's like, you know, how do you solve a complex problem? You break it apart. You know, what are the implications of breaking it apart? How can you break it apart such that it, you know, severs the fewest interconnections of concerns? And the method is basically you go out and you get all these, what do you call fitness variables? They would correspond to issues. You go out and you get all these concerns, design concerns, and you put them in a hopper, and then you start hooking them up to each other to represent connections between them and interactions, such that if you go and try to solve one problem, you have to remember that this other problem is affected as well. And that's what that's all about. And then it's all about the math of how to pull that apart. And so what I discovered very early on was that that part is a shitload of work, going and getting those design concerns. And it's the same thing as the behavior sheet where, you know, you got to write down all these things. And I was like, well, what if you had a database or like a website where these concerns would just get stored and accumulate? And then like you could apply the mathematics to it whenever you wanted to. Turns out actually like it's not even really necessary. I'm just finding from experience, because like if you can just like navigate around in it, like that's enough. You don't have to go and like try to, you know, like that's like almost like, I mean, when Alexander was doing this with Heidex, which is what it was called, the algorithm, which was just a sort of iterative min-cut kind of partition thing. There's been a shitload of scholarship on that in the last like 60 years. So, you know, we're good to go on that. But the idea or the situation rather is that there's still this problem, this effort of having to go and you know, go and get these individual things, and that's just like a costly thing. And now later work, I'm like, well, you know, some of this stuff is more perishable than other stuff. So this sort of thing that the specificity gradient is what I called it. You know, if you're like, I don't know. So I did talks on that. I spoke at conferences about this. I wanted to be able to actually implement that. It's trying to make it cheap. It's actually, I don't think accurate estimates are even a good thing to try for, actually. Because really, like, what needs to happen is that you have to spend less money on the thing than the thing is valuable. And that only gets a little bit different when like time is directly involved, when you've got to like actually have a thing out the door by a date, otherwise it's worthless. But so I did a whole other thing about that. That is the methodology talk. This one. This is where I make the argument that trying to do cost estimates is dumb. And I can recapitulate that right now, but I mean, if you're interested, I can go through that argument. But I have to re-up my my gin. So let me go and do that. Okay, that should. Actually, I think I'm gonna try to. I'm gonna try to fiddle with this. Let's try that. Still clipping though. That's. That's weird. Like, why am I clipping on the forehead? Whatever. All right, Everett, waiting for you. If you're watching on YouTube, I'm talking to Twitch. Because I'm streaming both at once. Because I know how to do that. It's actually very easy. You just like get Nginx. There's like a 2-line config. I have it running on my VPS. I just VPN to the VPS to the multiplexer that goes to both. It's very simple to set up. If you're me, or other people too. But yeah, actually let's just go to there. I don't understand why I'm like ghostly though. Is it just my shirt? Just the fact that I'm wearing like a shirt that's too close to the green. Okay, waiting forever to get his beer. Screwing around on the internet. Let's get that back there. Yeah, let's just actually mess with this again. Oh, no, you're a robot. How do you frickin' do this again? Ban this bastard. You're a robot. I always find the controls in Twitch like incredibly clunky. Internal error. You piece of shit. Seriously? That's fucking worthless. I don't understand why the color. You back yet, Everett? Okay, whatever, we're screwing with that. I'm way too yellow now, though. Ooh. That's better. Sort of. How do you just ban this bastard? internal error. Jesus Christ. Okay, there we go. Everett, waiting on you, buddy. There you go. Yeah, okay. So, the big idea has to do with, so, you know, people in the business of software and the people who pay for it, they've always got two questions on their minds, right? How long is it going to take? How much is it going to cost? Now, up until AI, you know, these were basically two facets of the same question, right? Like, how much is it going to take and how much is it going to cost is like pretty much the same question, like with a factor attached to it, right? So, you know, we'll just bracket the AI part for now because it's not material to what I'm talking about, like, because it's a capital thing. So effectively the idea, again, it goes back to, let me just get my old script for it so that I can remember it better. So really the question is like, you know, if somebody asks you how long is it going to take and how much is it going to cost, like, how do you answer that question, right? Like, well, you need to know like what you need to actually do in order to answer that question, right? Like, you need to know, like, with great detail, you know, what you actually what you're being asked to perform. And I have found, at least, that yeah, exactly. And so, you know, but I mean, even then, you can't like give like if somebody wants you to commit to a number, yeah, I mean, it's called paid scoping, right? But if you are in like a if you're in a like a what's it called context, if you're in like a full-time employee context, you know, you've just got a boss and the boss wants to know, you know, and you don't necessarily have that opportunity. But you know, like, how you get that answer though is like, how do you do it? Like, you need some sort of forensic information. You know, you got all sorts of sources. You may have like timesheets from other stuff. Like, you may have, you know, there's all sorts of things that can contribute to this. But the basic problem is that there's a lot of it's an information problem. So I'm just getting a message here. So I would say like another question to ask is like, why do overruns happen? And I think the answer to that is you basically get surprised more than your budget for surprise, because like how people typically do it is they like guess. I mean, this is how I've seen it. They guess based on the thing that needs to happen based on things that they've already done. You know, they may have timesheets that can like help tell them or whatever, or maybe they've just done it a million times, like, and there's really no different. and then they, guess 2 standard deviations to the right or something like that, and and then that is their estimate, or they'll come up with some like folk formula that's like, oh, we double it and we add this much or whatever, something like that. And I would argue that the problem is that software is actually fat-tailed. And so, or software development is fat-tailed. Lots of things. It's not just software development too. Like it just so happens that software development is something that a lot of people do that actually just like has this characteristic. But a lot of other stuff has this characteristic. Like development, in a movie has this characteristic, like that kind of a thing. Or writing Robert Caro's writing frickin' The Power Broker. Whatever, that kind of thing. It's just got this like insane, like you just have no way of knowing what the scope is going to be. And so that's not a bad idea. Hour, order of magnitude, days, weeks, and months. I personally find I can't do anything in under 4 hours anyway, just because of the there's. Yeah. Parkinson's law. So suppose you were trying to scope a project though. And again, it's like it is I just personally, I think that the question, like, because it's fat-tailed, the idea of just estimating based on adding and multiplying is just wrong and bad. It's just wrong and bad anyway. But basically the sort of idea of a mean variance, we've seen this thing this many times and it would took around this long, with the standard deviation of what if you wanted to get we're not doing that. We're doing, if anything, we're doing the mode, it usually took the 3 days or something like that. So basically, though, is if you think about what software development is in its very nature, is finding information out about stuff. And so you get surprised. That's what finding new information is about. And then you go and you look, and then you find out that the surprise has a surprise, and the surprise has a surprise has a surprise, and the surprise has a surprise. So you get into this sort of there's this situation in the contours of it. Again, it's not just software. It just so happens that software has a lot of economic activity happening with this characteristic. And so you've got this sort of fundamental situation where there is this sort of generating, this sort of surprise generator. Now, my sort of whole argument is the deck is stacked against you, and it's stacked against you because when you think about composite problems, the whole thing about Christopher Alexander notes in the Synthesis of Form is he's if you go and you prescribe up front what the categories are of thing, chances are you're going to get it wrong. You're going to get the topology, the decomposition, wrong by coming up by sort of over prescribing the structure. And if you think about a set of n elements, so n elements being n design concerns, the possible ways that you can partition that set is 2 to the n. So, you know, whatever, 2, 4, 8, 16, 32, 64, etc. Like it goes up very quickly. And so like the idea there is like, okay, so you got a project and you're going to decompose it into parts. You have a 2 to the n minus 1, that's 2 to the n minus 1 ways of getting it wrong and one way to get it right. And then if you want to put those parts in order where there's a dependency, and like let's say that you've got a process where, you know, you've got, okay, like you've got a process where you've got 5, let's say you got 5 steps that are like your process or your project aggregates up into 5 steps that that need to be done in a certain order. But let's say that you need to do them in 5, 4, 3, 2, 1. But you say we're going to do them in 1, 2, 3, 4, 5. And again, this is not the 2 to the n, but this is n factorial. So 5 factorial is 720, or sorry, it's 120. Sorry, 6 factorial is 720. So again, 5 steps in a row that have to be done in a certain order, and you get the order, or you have a 1 in 119 chance of getting the right, or sorry, 1 in 100 and 119 in 120 chances of getting it wrong versus getting it right. And then of course you add one more thing, and then it goes up to 720. And then but the penalty is not the same. The penalty is like a triangular number. So like let's say like you do it in 1, 2, 3, 4, 5, and it's like, okay, well you do 1, can't do it. You do 2, can't do it. You do 3, can't do it. You do 4, can't do it. You do 5, oh, finally, okay. 5 is done. So we go back to the plan. Do 1, can't do it. Do 2, can't do it. Do 3, can't do it. Do 4, okay, finally, etc. So that's like, again, 5 elements is a triangular number. I think it is, n squared, oops. I think plus n over 2. So 5 squared, 25, plus n, 30 over 2, 15. So like, imagine like a toy model where each one of these takes a day, and you think, oh, it's going to take 5 days. Well, it's like, oh no, it takes 15 days. And so like, now again, if you thought that like, that n was actually 6, this would be, again, 36 plus 6, 42 over 2 is, what am I saying, 21. So if you were like, I'm going to triple my estimates, well, you've got this nonlinearity where if you had 5 things and you tripled your estimates, you would be fine. But if you had 6 things and you tripled your estimates, you would be fucked. And so, like the sort of methodologies for, the sort of folk methodologies for, padding your estimates is just, they're just not like, eventually you're going to get, these overruns that are just too goddamn big for any padding that you're going to do. And the reason why is because they're fat-tailed. And if they're fat-tailed, which I submit they are, then like no amount of padding will satisfy. And so we need to look at other ways of organizing
basically controlling resources. And again, the only constraint really, like the important constraint, is that the thing costs less than it earns. And so I submit that there's another strategy that you can use, and that is a thing called a Fermi estimate. And so a Fermi estimate is like how many left-handed piano tuners are there in the greater Chicago area or something like that. Or it's the Drake equation is a Fermi. So how many, intelligent civilizations are there on other planets or whatever in our galaxy? A Fermi estimate is a way to come at accurate estimates, but you come at it rather than adding up and adding up from zero, adding and multiplying. You start from a value and then you subtract and divide. And what you find is that the error actually gets smaller as you do that, as opposed to getting bigger from adding and multiplying. And so if you said, well, rather than how long is it going to take and how much is it going to cost, trying to answer that question, because this is the thing, is like everybody is trying to answer that question without asking the question, is this question the right question to even ask? Because again, what's important? What's important is that it makes more money than it costs. Or, yes, you absolutely need to want to know as early as possible if it's too expensive and you need. Now what I'm going to say is adding up and multiplying just as a strategy for producing estimates is expensive because you have to do it exhaustively. You have to eliminate all the sources of surprise. But if you could, say, ascribe a value to the outcome, a marginal value to it, then it becomes a lot easier. Because, I don't know if you've noticed, when you're doing estimates and you don't want to do the thing that you're estimating, what ends up happening is you say, it's going to cost, it's good. We got to do this and we got to do oh God. And then what ends up happening is you stop because you've made your argument at that point. You don't do the exhaustive calculation of figuring out the cost because you don't have to. You just have to go to where it sounds unreasonable and then you stop. Now, I submit that all software has a value per run. And, you can think of some software that gets run once, like Stuxnet would be an example of software that got run exactly once, at least in production for some value of the term. And then you've got software that gets run billions or trillions of times a day. And so, and then you can sort of say that software takes, sort of partakes in, so the farther away it gets from the interface or the farther away it gets from actually doing something, it'll still sort of partake a little bit. So whatever XOR in the CPU or something has got a value per run, and it gets run 1 billion times a second, in every computer in the world, kind of a thing. It adds up though, because nothing would work without it, kind of a thing. So you can sort of make this argument all the way down from outer facing, you can buy a product and the product does this thing. You could peg the value per run at every time somebody starts up the app that you sell or something like that. Or, whatever, you can have some kind of a function or whatever. But bottom line is you can sort of create this, just kind of how ad people have a CPM or a CPA. You could do a value per run. And then you can say over the next 5 years or over the lifetime of this thing, how many times is it going to be run? What is the value per run? And then you do the discounted cash flow thing for it. You could say this is sort of the lifetime value as of today of this thing, if it existed. And then you can also like they're basically at this point, what I'm trying to say is the math becomes a shitload easier because it's not contingent on nearly as much data. You don't need nearly as much to figure out whether or not the thing is going to be worth doing. And then your sort of left side estimate comes in where you're like, all you've got to do is you got to say like how much effort is this, like if what is the minimum amount of effort, like, or not even the minimum amount, like what are the things that we have to do to make this happen, and you just keep adding to it. But like the value on it, which again you can discount the shit out of. There's all sorts of discounting functions that you could attach to this thing. Again, we are not there yet because I haven't made the software to even do this yet. That's what we're doing today. But the idea is you will be able to basically say like, okay, well, this stuff, like whether or not this particular module or this particular feature, function, whatever is worth doing, you will be able to tell very quickly. And even if it's like several degrees removed from a sale, you will be able to tell because it's a freaking dependency and you can just track the dependency graph. And that's like another argument for putting this thing in a graph is because you can actually compute over it as opposed to just looking at it with your eyeballs. So, like, that's the general idea, is it sort of like coming up with a way to do resource management in software development, at least at the outset, but other stuff too, where you're looking at it from like a anti-fragile, whatever, optionality, if you want to call it that, like perspective of where you assume the thing is fat-tailed, you assume that you have no variance, and because you have no variance, you've got no standard deviation. You got no standard deviation. You can't estimate based on standard deviations. And because of that, you have to have a different strategy. Especially when the nature of the project is so overwhelmingly dominated by going out and getting information, which could trigger having to go out and get more information, which could trigger having to go out and get more information. What are you doing right now that's impossible to put a value on? Okay, it's a small startup. Like, if it's ever going to be sold, like if it's ever going to be like, if it's going to be something, if you can trace it to something that, like if it's a small startup that's pre-product, pre-revenue, that's tough because it's all speculative. If it has a product, obviously, like it's like if you can say, for instance, that like the thing that I made got somebody to buy the product. Like if you can say that, then then you can actually attribute that sale to the thing that you made, whatever the heck it is. Doesn't matter what it is. And it could be like, oh, like I really like the confetti effect when you gamified this thing or whatever. Oh, that was so cute. It made me want to pay for it. I don't think anybody would do that. Maybe they would. I don't know. But like, the general sort of gist of it, the general sort of idea is like you can always, like as long as you can trace, like, I mean, you sort of think about like about it this way is like you can come up with tables of like stuff that, I mean, I had that in mind. I had it like, I just was going to say like, it doesn't, I mean, so I mean, shit. Like I was working at a company, like they were making these pizza boxes, these like 1Us, and the 1Us were like leased, like they were, you know, and it was like a B2B thing, and like it was corporate money, and like you would pay, I don't know, $5,000 a year for the base model. Let's say, I don't know, I don't know what the number was, but if I could make something that convinced a customer to buy that product, then that object, that piece of code or whatever is worth $5,000 because they wouldn't have bought it otherwise. And then of course, like, you know, or like if you introduce a thing and like because of it, like two customers don't churn, like they like, oh yeah, we were gonna cancel our prior thing, but we didn't cancel it because of this thing. Again, you can sort of like, it's not hard in my mind to just spreadsheet math this. Like if you had something, again, like there's a certain sort of set of you know, business model thingies for this. And then again, like you can compare it to other stuff. So like you could be able to compare it to, like, let's say like you were doing a loss leader and like the alternative was to buy advertising. Well, you know, and like, was the thing cheaper than advertising? Like, then there's your value there. Like you can always get at the value. As far as I'm concerned, you can always, like, it gets more diffuse as you move inward from the sort of perimeter of the organization. Like the farther away you, like, I mean, shit. Like, okay, I made Intertwingler, which is the substrate, the application server for this thing. I made that. I have no idea how many thousands of hours it took to design that because it's sort of like diffused over like over a decade and a half or something like that. It was something that I knew was valuable because this thing was not possible. I mean, I had a prototype of it that was running on this sort of hard-coded shit that didn't work properly. But, you know, the work that I'm doing today about adding all the extra stuff to it, was not possible. And so I needed to write Intertwingler to make that possible. So now it's just a matter of like adding some CSS things and doing some front end work, and then it just JFW. Just fucking works. You know, and so like the value of this to me in the short term is like I can go out now and I can solicit, you know, contracts, you know, as a consultant. This thing is like way too rough to just get turned out as a product right now. But I can go out and I can go out and sell my services facilitating, basically doing this modeling in companies. And that is, you know, I don't know. So this is worth, let's say it's worth like a couple $100,000 in the first year or something like that. I don't know. We haven't crossed the threshold quite yet for this, but, you know, it's not an unreasonable amount of money to say what Intertwingler is worth, what made this possible. So again, Intertwingler is not, it's a piece of middleware. It's an application server. It's not a product in its own right. This thing that's running on top of it is hopefully eventually going to be, it's not going to look like this forever, but it's hopefully eventually going to be worth a lot of money because of its characteristics that are not just this, it's a bunch of shit. So, you know, and again, it's like, it's going to have a sort of, yeah, it's got a value per run basically. And the value per run right now is not as much as it will be in the future, but it's still like you can say, okay, you know, let's say if I continue on for like, so, you know, if I have this, this thing and I go in and I don't know, like the sort of the tentative scheme was if you hired me for like, let's say $5,000 a month as a sort of on a retainer, you know, like I will be the curator of your this thing for you, where this is just running in an instance and like you can run it on your gear if you want. I can run it if you want. I got Docker images. We're good. You know, and then like we would meet once a week or something like that. And then I would also do stuff offline where, you know, I am just curating this graph of stuff and then your job, you use it internally to like make decisions and whatnot. And so like, is that worth it? Well, you know, what would it cost? What would it be? The next thing is you would have some kind of an intern or something like that that would do that. Could you even, has what been tested? This is not my model. This is IBIS. This is issue-based information system. This is these guys' things. It has been tested to the extent that they did it in the 1969. And, you know, people have been replicating it for freaking centuries. Now, the stuff that I was talking about with the process model stuff and like the value-based estimation stuff, no. I have people who are interested in it though. And again, it hasn't been tested only for lack of infrastructure for just making it even manageable to just execute. So, I mean, I have clients who like somebody is paying me right now to add the process model ontology onto this thing and like package it up for him so that he can use it. There's a lot more boring stuff that this thing can do that is not just at least in principle, there's a lot more boring stuff that this thing can do can be applied or just used out of this. So it's not just software. It is, and I mean, like I've been using this thing also like in my consulting stuff since 2013 when I wrote it. It hasn't been central though. That's the difference. The difference is like this has not been a major. This has been something that kind of been doing on the sly on the side, mainly to like deliver certain artifacts that like would just be too much effort to not. And so now like that is just like, so like those concept schemes, for example, like, so if they're not interested in this, I still use this. Like if they're not interested in this, because like there's other stuff. And I mean, again, I literally just ported this like 2 weeks ago, 2 weeks, a week and a half ago to Intertwingler before it was using this like sclerotic old backend that like couldn't have anything added or expanded onto it. Yeah, I find like hypermedia is really hard to talk about because people just don't fucking get it. They just don't get it. They don't get why you would want it. And it's weird. I don't know why they don't know why. I don't know why they don't get it. So like I kind of instituted like a no hand waving protocol policy for, I don't remember. Like, so I spent like the story of this particular tool. Again, I did the vocab in 2012. I did the tool in 2013, and I only did it to test that protocol, the RDF KV stuff, so that It was a purely technical thing. And nevertheless, I was like, this is actually kind of useful. And I was using it, but it had this limitation in the back end, like, because it needs it needs to be able to do inferencing. Otherwise, it's just a goddamn mess. And so I looked and looked at because the thing is like I had it written in Perl back in, because that's what was my daily driver for 20 years. You know, I had it written in Perl back in 2013. There was no RDF reasoner in Perl in 2013. There probably still isn't now too, because there isn't one in Python. There was, but it was broken and abandonware. You know, there isn't one. It turns out the only languages that actually have a freaking RDF reasoner are Java. And Java has like a dozen of them, but there's no reasoners in any RDF frameworks except for Java. And I was like, oh shit. So I guess around like 2017 where I'm like, well, I hate Java, but I don't mind Clojure. So like, can I wrap Jenna in Clojure and then use that? And then I was like, well, this is like months of work just to do that. And I just don't have time in 2017. And then in 2018, I was working with a client who was a Ruby shop, and it turns out they wanted me to teach them about RDF. It turns out that the Ruby RDF framework has a reasoner. And I was like, oh shit, okay. And so I was still poking around, and it wasn't until I got a grant in 2023 that I could really like move forward on the application server and implement that. And that even still took like another several months after that initial thing. I think I was like working on it till it's like through 2024. It was probably like March 2024 that I finally got that shit working. And then again, 2024 was mostly stuff that was not that. And again, it took until now, like I think it was August of 2025 when I started to port this thing over to Intertwinkle. And that was like sever the front end from the back end and then start filling in the back end in a way that makes sense and is sort of reusable. But like, you know, I was talking about hypertext, dense hypermedia, I called it. As far back, I mean, I think I said dense hypermedia was probably a later term that I used, but like I was talking about hypertext like as far back as 2008. And the idea, like the thing that for me is like if you have a complex thing that you're trying to communicate and you want to like get it into somebody's head, you want to like get the information into a person's head. Like the way that people do this is with documents. And what I find is that documents suck shit in a lot of ways. Like documents, like a document is how would I put it? Like a story is useful for selling. It is useful for getting people interested and selling the thing. But if a person's already sold, like if it's like, I'm going to come to your restaurant, I just need to see your address. I don't need to see the 3,000, or I'm going to make your recipe. I don't need to see the 3,000 word fucking blog post on top of it. Because I've already decided I'm going to make your recipe. What I need to see is I need to see the ingredients. And so like the situations where you are communicating information for the information's sake and like you don't need to worry about selling the fucking thing. Hypertext is very interesting for that. But again, like like, I think that the sort of central problem with hypertext is that your normal person just does not know what it is and what it can do for them. And they don't fucking care. And so what you need to do, if you are interested in hypertext and you're interested in making hypertext, you're interested in getting paid to do hypertext, is you need to make hypertext for free and a fair amount of it and put it out there and have people experience it. And like, that is the only real way you can do it, because nobody fucking knows or cares otherwise. Nobody's going to care that it's hypertext. Nobody's going to, like, it's just, you know, and it's been interesting because, like, there are, like, when you think of hyper, like, well, we have the web, like, hypertext. What do you mean? Like, there it is. And it's like, I would say that the web is sparse hypertext. And part of that is, like, if you were going to, like, take any website and you were going to cut off the main navigation and the, like, footer, ancillary content, sidebar, whatever, you would basically have, like, a Word document, you know, might as well be a PDF at that point, because there's no links left. It's just a document. And then you're supposed to start at the front of the document and read it to the end in the, like, most boring and least effective, efficient way possible. And that works for some things. It works if that's the point. Like, it works if that's, like, if what you're trying to do is consume a story and you're trying to be engaged and interested in, like, but it's like, if you just want information, like, it's a shitty way to do it. And then, of course, it gets out of date, and, or, you know, it gets, like, the links rot and whatever. And so there's a lot, like, I mean, the whole job of, like, Inner Twingler was, like, fixing that part, like, fixing the boring shit that has to do with the web, like, all of the boring, shitty things that you have to do when you're making a website, like cropping images, or, like, you know, remembering what you renamed the URL of this to that, kind of, like, doing that shit is really the sort of major job of Inner Twingler. Try to, like, eliminate, like, where the fuck did I put that? And then once you've sorted that out and you sort of look, like, you know, graded that, then we can talk about other things like this tool on top of that. Because this tool, like, one of the things that's kind of interesting about this tool is it doesn't care where it is in the address space. Like, it could be anywhere. You know, the URL could be anything. Any URL could be anything. It doesn't matter. Like, it's not contingent on, like, where it, I mean, obviously, like, URL has to be right, but it doesn't, the actual, like, it would be just as happy if this said potato on it or whatever. Like, it would be just as happy. Yeah, exactly. Like, the one of the sort of terrible problems of hypertext is that none of it works until all of it works. It's like, you know, you've got, and I've also found too, making hypertext, like, so when I started out, like, when I made my website, my like DorianTaylor.com, I made that in 2007, 2008. I think I had something different in 2007, and I was like, I had, like, a few rules. Like, I was like, I want to make it so that, like, it doesn't take up more than, like, no page takes up more than a screen, and, like, pages can be, like, they can be reused, and also, like, if, like, I don't publish until, like, I have, like, exhausted, like, the set of, like, neighbors that have all been made. And, like, what I found was, like, that was such a pain in the ass. Like, authoring, like, proper hype, like, I was like, I want everything to be, like, little and short, and I want everything to be linked together really densely, and I want to be able to transclude stuff, and I want to be able to, like, do all these things that are sort of hypertexty, and do stretch text, and I wanted to do all this cool hypertext stuff, but it was such a pain in the ass that like just even sort of like one of the things that I sorted out very, very early on that was one of the sort of central parts of Intertwinkler was the URL resolver, was distinguishing persistence from publication. So like it doesn't matter now in a lot of apps these days where, or you think about settings and stuff like that on a Mac where you just change the setting. You don't have to like save the settings. You just change the settings. But you in the sort of conventional sense, like you want to write something, you want to write a document, you want to write a thing. You gotta come up with a file name for it. You got to decide where it's going to go. And in the same sense as a URL. Now, what if you had this constraint where like, okay, like anytime I go off in a parenthesis, that's a new page. Oh shit. Well, that means I've got to come up with because we're going to derive the URL slug from the title, which means I got to come up with a title. But you're told, in elementary school or high school that we come up with the title as last. You don't come up with the title until you've written the thing. But like, what are you going to call the file? If the file is supposed to be derived from the title, you're not supposed to come up with the title. Well, you could rename it. Oh, but if you rename it, then you've got to worry about the what happens when somebody tried to link to the old name. I mean, this kind of shit just seems like a problem that can just be wave your hand, go away. Now, it occurred to me that a while ago, 1999, a while ago. So I was working on using Apache modules, Mod Perl, 1999, and one of the things that was very obvious, could have been early 2000, I don't know, late 1999, early 2000. So one of the things that I found was that that you can make the URL be anything. The code, like there's nothing in it, like the structure of a request URI. There's nothing in the protocol that says it has to map to files. There's nothing in the protocol that says it has to have a terminating slash on the end of a thing if there's no file. The file extensions are a made up thing in HTTP anyway. That comes from a header. It doesn't come from a file extension. The file extension is completely useless in HTTP. There's so like furthermore, like the path, like a path can be anything. Path can just be line noise, and the only thing that matters is that the request URI is basically like a hash key. And it's like, oh, okay. Well then, all that time I was spending trying to decide on the best hierarchy for the structure was like a humongous waste of time. It was exactly the same problem as that combinatorial problem of like putting things in order or putting things in a structure and trying to. It's like you can just not do that. Or you can delay that indefinitely by just saying /UUID. There's your slug. You got 122 bits of entropy because you got 128 minus 6. 122 bits of entropy with a frickin' UUID as the single path segment, and you can see that here. Probably not very well, but you can see it there. And you can have, what's 122 to the 122 things? There's a lot of things. And then you can come around later and you can decide like what that's going to look like, path-wise later on. So this sort of general problem of distinguishing persistence from publication was like something that I figured out very early on, and I was like sort of duct taping like, in the original version of Intertwinkler, all it does is it just crops out a friggin' rewrite map. You put it in your document root and you pick it up with not an htaccess because it's not allowed, but so that's the way that like all my sites are working right now, is they're just static. All of the files are these UUIDs in the root directory, and then they got rewrites on them. But the thing is the point is the amount of like the amount of like consternation that happens about like trying to figure out where to put stuff on a website. It's like you don't actually have to do that. You don't have to care. And like with like REST, like HADOS, whatever, you know, the hypertext is the engine of application state. You don't have to care. You can just IPFS works by DAT. I have no idea. I think DAT is kind of moribund. But IPFS, they have a SHA-256 hash on the first block of the thing, which like is like a Merkle tree or something like that. And so like the identifier is the it is what it's pointing at is it's pointing at like a chunk of metadata with like a chunk of payload that like, and then metadata tells you where the next payload is or the next object that's going to be a chunk of metadata. So the hash is not of stuff, it's of metadata and stuff and a piece of stuff that shows you where so it does the sort of like route chasing thing. This is just you mint the identifier. This is not, so like I will eventually like so one of the things that I've found that have been sort of asked for on this is this sort of notion of like, so I have like a mechanism for basically like building up like a tree or building up like a you know, a nice human facing URL path, you know, thing for this. And I also have a registry for query parameters as well. And like you can construct a sort of object out of it, and they get passed down to the thing, and the semantics are handled a certain way and so on. So that's a neat, fun thing. Yeah, like this thing, like the way this works is like fully HADOS. Like it's fully, like all it does is follow links. The URLs could just be switched around. Doesn't matter. They could be anything because it's all, and it follows links, and then it follows links based on RDF. So the only like URLs it needs to know are the RDF types and properties. And everything else is just following links. Like all the instance data, it doesn't matter where it is. It could be anywhere. Yeah, anyway. So, like, the point, really, like, the point with, like, of Intertwingler is just, like, to make this shit as easy as possible to do. Because what I found, like, what I've definitely found making, like, an RDF-based web app is, like, an RDF-based web app, like versus an SQL one. SQL one, it's like you want to add a new thing that connects to this thing. Well, you got to make a table for that. You might have to like make a log table. You're going to have to make a log table for that. Hopefully you're going to have to make a materialized view, or you're going to have to do triggers, or you're going to have to do something that like does all that. You got to like, you know, you're going to come up and you got to make up shit. That's a whole day. Whereas this is like, oh, you want to connect this thing to that thing. You just make up a term and then you do it and it's done. It's just like literally, it's like, what was I doing all day? I was making, you know, palettes in Sass, and then now I got to do front end, and then it's going to just be done. It's just going to work. One thing that's been frustrating, I think you can relate to this. I got really into a thing of concept. So, but and then a few years later, now you're one of the... Me? I'm one of the... Sorry, wait a minute. I'm one of the few people in the world building the tool and talking to the standards people, and they also don't know, or I don't... Or you mean you? I really got to get like both chats up on the screen. But you see the laziness. Oh. Are you talking like at Proto? because yeah, they've like gone done and reinvented some wheels for sure. It's kind of interesting in a way because like activity streams rather, is an owl ontology. You can go to their GitHub and like get it. And then like what they do is they strip off the owl, they strip off the RDF and then just make it JSON. So it's like they're using it to do the modeling. Well, yeah, I'm finding myself building all the tooling because, like, again, it goes back to my, like, no, hand waving policy. Like, it needed to, like, I could not explain this to somebody else and have them make it. Like, like this stuff needed to exist to even have a conversation about it. And, like that was it. Like, I look at it this way, like analogically, like the analogy is like, imagine you're trying to explain something to somebody and you're trying to like, you're waving your hands around and you're trying to use words and whatever, and they just don't fucking get it. But then you draw a diagram and they're like, oh. And what I submit is that these software artifacts are kind of like an analogy of like a diagram. To the extent that, like, so what do? Like they occupy the they occupy the space of, like they do things over time, which is sort of like what you need to experience. Like just looking at this screen doesn't do anything for anybody. And it's like nobody's going to give a shit about the content of this thing either because it's not the content you care about. You're not my client. You don't care about this process model ontology necessarily, right? Like he does, you don't. I mean the royal you in this sense. And in the sort of the situation is like content driven, software where like there's barely any software. Like there really is not a lot of software in here. There's a fair amount of content though, and you're not going to care about it if it's not your stuff. It's kind of like, like if you sell a house and like you have to stage it because like everybody coming through there is such a, like their imagination is so impoverished. They can't walk into an empty room and be like, oh yeah, I can imagine the couch going there. They just can't. They need to see a real couch there in the room. So you have to pay the stager like however many bazillions of dollars in order to, tens of thousands of dollars to put a freaking couch there and put a picture on the wall. And it's because the people you talk to are most likely to talk to, their imaginations are just so impoverished. They just can't get there. And, I mean, it's not everybody, but it's going to be most people. It's just going to be statistically likely that you're just not going to be able to find some, like, in your travels. And so, like, how do you deal with that? Well, what you do is you make the fucking thing, and then you broadcast it. You use it. You use it in front of people, and you show them that it does something. Yeah. And so, anyway, it's like 11:30. I'm gonna go and chill out, I think. This is actually, and I think the other thing too is also this is just too goddamn slow right now to do the actual substantive stuff, which I have been talking for 2 hours about but not actually doing it. So I'm gonna take 2 loads off of my system by turning off. Yeah, no problem, Everett. By turning off OBS, and then I'm gonna try to chug on this for like a little bit longer before going to bed. All right, sayonara.